Okay, so today we're going to talk about similar polygons. We're going to learn to identify them. We're going to find a scale factor. We're going to write similarity statements and do some word problems. So similar polygons basically have different sizes but the same shape. If I say that triangle ABC is similar, and that means similar, to triangle DEF, it means that all of my angles have the same measure. However, the sides are proportional. So if I look at this triangle, it means that angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. Okay, and then it means the sides are proportional. So we have AB and DE, so AB is 10 and DE is 15. Okay. And basically we can write an extended proportion that says AB is to DE is equal to BC to EF. So BC is 8. EF is 12, and then lastly is also similar proportional AC to DF. So AC is 12 and DF is 18. Now if you reduce all of those fractions, 5 goes into both 10 and 15 and it becomes 2/3. 8 goes into 12, both 4 divides them, we get 2/3. And 6 divides 12 and 18, and that also gives us 2/3. So our scale factor from ABC to DEF is 2 to 3. Okay. This up here is a similarity statement, just like we had congruent statements when we were doing congruency. We have similarity statements as well. All right, so are these polygons similar? If so, we want to write a similarity statement and state the scale factor. So if I look, I have A congruent to J. I've got B congruent to K. I have angle C congruent to angle L. And I have angle D congruent to angle M. So far we're good. All right, all 4 of my angles are congruent. So let's look at the scale factor. I've got 8 to 14 from here to here. I have 8 to 14 again. Then I have 8 to 14 again. I'm not going to worry about writing that down again. And then I have 12 to 21. So if I reduce those fractions, 2 goes into 14, 7 times, and 8, 4. And then 3 goes into 12 4 times, and 21, 7. So yes, these are similar. So our similarity statement would be polygon ABCD is similar to, you use that tilde like you use in Spanish, JKLM, and its scale factor from the small one to the big one is 4 to 7. Okay, scale factor is important. If I wanted to say that the scale factor from the big to the small, you want to make sure that you know which way you're going, and that would be 7 to 4. All right, so now I have that these parallelograms are similar, and we want to find the value for x. So x is on ST, and ST is similar to XZ, which is 20, so x over 20. And then we can pick what other, we know these other sides, 16 to 24. So 16 is on the small parallelogram to 24. Now, it doesn't matter how I set up that proportion as long as things are together. I also could have had x to 16 equals 20 over 24. they're going to give us the same answer. So to multiply, we get 24x equals 20 times 16, which is 320, I think. Calculator stopped working. And then if I divide that by 24, I'm going to get x is approximately 13 1/3. All right, so let's do some word problems. We'll have a basketball, large cement court is being poured for a basketball hoop in the place of a smaller one. The court will be 20 feet wide and 25 feet long. The old court was similar in shape, but was only 16 feet wide. So you want to find the scale factor of the new court to the old court. So the new court is 20 feet wide and the old court is 16 feet wide. So our scale factor from the new to the old is going to be 20 to 16, which reduces to 5/4 if I divide both 20 and 16 by 4. Okay, and then they're asking me to find the perimeter of the new court and the old court. So remember, perimeter is we're adding up all of the sides. So the perimeter of the new court is 20, 20, 25, 25, so 90. And we can use this scale factor to find, we've got the width to find the length. Or this is just a linear measurement, we can use the perimeters too. Okay, so I can set up 5 to 40, where 5 is the new court, and we know the perimeter is 90, and the perimeter of the old court we don't know. So if I cross multiply, I'm going to get 5x equals 360, and then if I divide 360 by 5, I'm going to get, I think it's 72, but I'm going to double check. You guys know me and my math. I can do calculus, just not arithmetic. And yes, it is 72 feet. All right, another example. A cartographer is making a map of Pennsylvania, and she uses the scale 1 inch equals 10 miles. The actual distance between Philly and Harrisburg is 95 miles. How far apart should she place the two cities on the map? So if I have a scale factor of 1 inch to 10 inches, so this is our actual distance, or 10 miles, we know that their distance is 95, and we're trying to find what it should be on the map. So our x would go with the 1 because that's 1 inch on the map. So I'm going to cross multiply and get 10x equals 95, and if I divide by 10, x equals 9.5. All right, so today we learned what a similar polygon was. We learned how to find a scale factor, write a similarity statement, and solve some word problems. So I want you guys all to have a math-tastic day.